Thank you. I'll begin with a word of prayer. So, dear Heavenly Father, we thank you again, Lord, for this opportunity to just meet together and to talk about math. And I thank you for these students. I pray that you just help us use this time wisely, just to draw together our thoughts for the semester, Lord, as we prepare for the final, Lord. In your name I pray. Amen. So what would you like to know? How to integrate by parts? Okay. All right, so I guess the first thing about integration by parts is to know when you can do it and when you can't. So how do you know when you can and when you can't? Well, here. One of these things is not like the other. One of these things does not belong. Which one is that? The middle one, yes. Very good. In fact, this is not integrable by elementary methods. You can't do that problem. Like that one. Yeah, this one is a u substitute. We let u equal what? U equals x squared, so du is 2x dx. In other words, dx is du over 2x. So we get integral of x times e to the u, du over 2x. The x's cancel, and we're left with 1/2 the integral of e to the u du. 1/2 e to the u plus a constant, which is 1/2 e to the x squared plus a constant. So that was a u substitution. Now, why can't we do a u substitution here? Well, it's just not the right format, right? If you try to make u equal to x, then you don't have anything to do with the x, and so by process of elimination, it has to be an integration by parts problem because we only know really 3 integration techniques in here, right? It's elementary, which means it's on our list of basic integrals. What are our list of basic integrals? Well, integral of x to the n dx, x to the n plus 1 over n plus 1, right? Or integral of dx over x, natural log of the absolute value of x plus a constant, or the integral of e to the x dx, e to the x plus a constant, and then integral of sine of x dx. But I want to. But you guys are mean to me. But all right, fine. Those are your, so that's the first method. It's an elementary integral. And of course, it can look funny, like this doesn't look like the first one, but it actually is, right? There's a lot. There's a lot to this, right? Understood. And then there's problems with algebra. There's u substitution, and then integration by parts. So integration by parts, the basic thing is we're going to use the integration by parts formula, which states the following: the integral of u dv is equal to uv minus the integral of v du. So in order to make use of this integration by parts formula, I have to identify u and I have to identify v. So this is kind of a generic type of example. If you have x times something you know how to integrate, what you want to do is let x equal to u. So this will be x is going to be u. dv has to be whatever's left over. So dv is forced to be e to the x dx. Now, in order for the u substitution to be a good one, you actually have to be able to differentiate u. Well, that's fairly safe here, right? But the other thing you have to be able to do is to integrate the dv. So dv is e to the x dx, right? So in order to be able to make this a good integration by parts, I have to actually be able to integrate dv. What's the integral of dv? V is what? What's that? E to the x. Very good. Okay, then I do this is equal to uv minus the integral of v du. My u is x, my v is e to the x, and I'm subtracting integral of e to the x du is dx. So integration by parts, it in some sense allows you to, I mean, it's not directly pulling the x out of the integral, but it's kind of the next best thing. Right? We can't pull x out of the integral, but this integration by parts technique kind of allows us to, right? Sort of heuristically. And so that's e to the x plus a constant, and there you go. Well, if we just, I mean, you can, again, you can switch the roles of u and v if you want, but we can just, if we just stick with this, we'll be fine.
Is it kind of, on one of the homework, it didn't work. I mean, maybe I...
Which one?
Homework number 17. This was number 5.
Now,
And number 4, just like all of those were just kind of, I didn't know which one to, yeah, number 4, yeah. Can you do number 4?
sure. Now, number 5 is maybe the hardest problem in your homework. The fifth problem, this one, or something like it,
Yeah,
this we have to integrate by parts twice. So the first time, we have dv, and we let x squared to be the u. I mean, listen, there's another, well, if it's okay, I'm going to blow your mind for a second here. How about this? Integral of x squared e to the x dx. Here's another way we could do it. This is the integral of x times x e to the x dx, right? So if I let this be dv, and if I let this be u, so u is equal to x, du is equal to dx, dv is x e to the x dx. What's v equal to? Mm-hmm. Yeah, I mean we can just drop off the constant in this particular.
so that's why you have to integrate.
Yeah, I mean, so if I use the previous example, I can just do one. So this would be u v minus integral of v to u, which would be funny. X times x e to the x minus e to the x minus the integral of v, which is x e to the x minus e to the x. Oh, this is weird. Dx. So this gives us x squared e to the x minus x e to the x minus the integral of x e to the x dx plus the integral of e to the x dx. But again, we know what the integral of x e to the x is from the previous, from right here, right? So that we get x squared e to the x minus x e to the x minus parentheses x e to the x minus e to the x close parentheses plus e to the x dx, e to the x plus a constant. So many e to the x's. Great googly moogly. Okay, so anyway, after the dust settles, you got x squared e to the x minus 2x e to the x plus 2 e to the x plus a constant. Is that a question or a scratching? Both, okay. Okay.
When you have an e to the negative x, I'm totally blanking. What does that do?
When I have an e to the...
Like, this is not my question, but if
Yeah,
you
yeah,
have
yeah.
an e to the negative x dx, what should you do?
Sure. Like this?
Yeah.
So this one, this is just plain old garden variety u substitution. Let u equal minus x. So du is minus dx. So this is integral of e to the u minus du. So it's minus the integral of e to the u du, which is minus e to the u plus a constant, which is minus e to the minus x plus a constant.
And so then if you're doing that for the IDP,
Yeah.
would you use the constant or would you not use it?
We end up not needing to use the constant because, well, the reason for that, how to say this? You can get away with not adding the constant. It ends up just being somehow another copy of the constant added. It's because if I take v plus a constant, right? If you think about v plus a constant, that ends up basically adding u times the constant from this integral. But it's also over here. So it's just kind of, how to say this? The constant somehow like cancels in this thing. It's hard to... Let me just summarize by saying you don't need to add the constant. Now, you guys asked me about the problem 4. I never did it yet. Sorry. Yeah. Yeah. Previous example. Integrating. So this, I mean, I'm overloading the notation here. This whole thing is dv2, let's say.
Why do we need to integrate
X squared. I mean, I could do it direct.
Oh, okay.
It's a different problem. It's problem 5.
You can't do it without kind of like taking out the x.
Well, we can do it. I mean, here, let me do another one. No concatenation of problems. Just one foul sweeping problem. Here you go. X squared. I'll do a minus x dx. That's annoying. I'll do it though. All right. So this will be my dv. This will be my initial u. All right. So u equals to x squared. dv, well, du is what? 2x dx. dv is what? E to the minus x dx. That makes v minus e to the minus x. The reason for the minus is this example over here, right? Or if you like, you can just think about differentiating my v and see that you need the minus by the chain rule, right? You guys see what I'm doing so far? So we do integration by parts. uv minus integral of v to u, which is x squared times minus e to the minus x minus the integral of minus e to the minus x times 2x dx. I find it helpful to clean up the minuses at this point in the calculation. So let me do another step. I'm just doing bookkeeping on the minuses. So I've got minus x squared e to the minus x plus the integral of 2x e to the minus x dx. Everybody with me so far? I'm going to do this completely self-contained. Over here, I combined two problems. I know that I probably shouldn't have done it. That's what you get for not giving me my sign. Let's see here. No. So as you can see, integration by parts is working its magic. It's reduced the power of x in the integral by 1. Right now we've got 2x instead of x squared. Step. Right, and to try to reduce the confusion, I'm going to call this one dv2, and I'll call this one u2. So u2 is equal to 2x, dv2 is e to the minus x dx. And this marker is dead. Oh well, a little bit long. Just a little bit. So du2 is 2dx, and v2 is minus e to the minus x again. Thank you. All right, so we've got minus x squared, e to the minus x, plus, and then what we have is u2, v2, minus the integral of v2 du2. Integration by parts formula again. Okay, so what is that? That's minus x squared, e to the minus x, plus, let's see here, u2, 2x, v2, minus e to the minus x, minus the integral of minus e to the minus x times 2 dx. Let's click, what's that?
How many times do we have to continually
2 times. Yeah, if I made it a cube, it would be 3 times. You say, please do that on the exam? Oh. But I could bring the sign back, right? No? I figure if I'm going to be like my 2-year-old. If I ask enough times the same question, eventually I'll get a different answer. So McDonald's is giving these Pokemon toys out right now, right? And like the Pokemon character that they give you is not the same as the card. They give these Pokemon cards. There's 2 things. It comes with like a little plastic toy and the card. But the card does not match the toy. And this is very troubling to Isaac. He's sure that he has taken the wrong card from McDonald's, because it should have, he's got this like little green snake thing, Eigen, I think it is, and or Agen or whatever, and his card is something else, and it's just very troubling. He has asked about this no less than 50 times in the last 2 days, I swear.
Does the answer finally be
Open notes? You really want an open notes? You really want my open notes final?
Wait, is the whole page like?
Front and back.
Yeah, front and back, printer page. Like you can use printer. You can use a printer paper. What's that? No, I mean Shakespeare, 23rd Psalm, the part of the Constitution we're actually enforcing. I mean, whatever you like. No, a piece of paper. At most, a printer paper. No poster boards. No. You want to use cardstock of an ordinary size? That's fine with me. I don't care. It could be a piece of wood the size of printer paper that has engraved the equations on it. If you want to tattoo on your own body equations equal to the surface area of a piece of paper, you're free to do that as well. I mean, whatever. Oh, I'm sorry. Wait a minute. Are we allowed to tattoo? Oh, okay. I lose track. Yes. Yeah, so like integral of e to the minus 7x dx is going to work out to minus 1/7 e to the minus 7x dx plus constant, yeah. And yeah, if you let u equal minus 7x, that'll be how to do it. Yeah.
This is probably a really, really, really tough question. But so you have the uv minus the integral of dv du, but you keep putting, like, for instance, right there, you have the v, but then I don't know. Oh, du. Never mind. That is. Never mind.
I'm sorry, I did that one day. If you guys had been absent like everybody else, then you would have been safe. But, oh well. It's your mistake, you came that day. Ha ha ha. Sorry, no. What am I supposed to do? I'm supposed to do integral of the natural log of x plus 2. something like this, right? So u substitution doesn't help you. All right, you can try, but it doesn't help. So pretty much integration by parts is our only hope. When faced with a log, generally speaking, you let the log be the u. And it's kind of by process of elimination, that's what you have to do here. And whatever's left over is the dv. So that's going to be uv minus the integral of v du again. Now here u is equal to the natural log of x plus 2. So du is dx over x plus 2. Right? dv is dx. What's v? What's that? X. Very good. You need to own that step if you're going to be successful at this technique, right? Let's see here. So that's uv, which is x ln of x plus 2, minus the integral of x times dx over x plus 2. I did this in class.
Yeah, I have a question.
Yeah.
I'm a little behind. But on the blue, down there at the bottom, you have 2x times g and then negative x. Wouldn't it be 2x times negative e to the negative x? Yeah, but that's right.
It would, but there's a minus in the integration by parts formula, and then there's a minus in the v, and then this, yeah, that. Listen, I worked it out this way in class already. I don't want to work it out this way again. Let me switch gears and try to, I want to do the different approach since we come back to this problem again. I mean, this is somewhat cumbersome because you have to face this integral. So to do this, you can let w equal x plus 2, etc. I would rather not do it that way. Let me show you the right way to do this integral. Okay? My imagination. Is that the wrong answer? I mean, I don't know. I've already used u and v, so I need something else. W is the denominator. So like that's how to do that kind of integral. I mean, fine, I'll do it. You talk me into it. All right, so I'm not going to do that. You guys, what are you guys doing to me? Natural log of x plus 2. So I want to show you a better way to attack this one is to first make a substitution, make the w substitution up front. If you do that, then you can do integration by parts on this. So what we're going to do is we're going to let u be the natural log of w, and we're going to let dv be dw. So u equals ln of w, dv is dw. So in this case, the w is playing the role that x usually plays. So what's du? Right? What's v? W, right? So we have uv minus integral of v du, which in this case is w ln of w minus the integral of v, which is w, du, which is dw over w. See, isn't that fun? So this time, we're just left with the integral of dw instead of this ugliness like we found in the other case, right? I mean, this is not impossible. This is not impossible, right? I mean, you can settle for this. It's ugly, but you could settle for it.
But that could be the whole answer.
I mean, you can do that integral is my point, but it's easier to do this way. So this is w ln of w minus w, and then go back to x. And there you go. We finished the thought another day in class on the other integral, right? We did do that integral, like, I don't know, last class, class before, recently. You guys are not giving me positive reinforcement on this issue. Let's see here. Fine. So if u is equal to x plus 2, du is equal to dx, and we're left with x du over u. And what's that mean? That means you need to figure out what x is in terms of u. X is what? U minus 2. So we have u minus 2 over u du, aka integral of 1 minus 2 over u du, which gives me u minus 2 natural log of the absolute value of u plus a constant, which gives me x plus 2 minus twice the natural log of x plus 2 plus a constant. So you take that, and it goes up in here, and it's the same answer as we got over here. See, I've got a copy of, I think I lost a, well, you see the minus in the ugly and the minus in the red integral go together to give you the plus 2 over here. You get 2 copies of ln of 2. You get the x ln of 2. That's already here. So you can, if you stare at it for a little bit, you'll be able to see that the answer we have here and the answer we have here are in fact the same answer. I'm just advocating that as being the easier way to do this problem.
So, it's the only time you can substitute your x plus 2 with w when you have a natural log or regular log? Or can you do it other times?
I think this is sort of generically like a good strategy. Like if I was so malevolent as to ask you something like integral of x plus 3 times the e to the x plus 3 dx, then like a smart move to start with here would be let w equal to x plus 3. And then you'd be back to this problem again with w playing the role of x. That's not a question you've had in homework modulo that one. But now that you bring it up, you're right. I can ask this kind of question. Because it is in your homework now that you point that out.
Which one?
Well, it's that one. That's the problem. This idea is in your homework there. Yeah, yeah.
Would you go about that the same way if it was, let's say, the integral of x ln 3x dx?
Oh. If I had integral of x ln 3x, like this.
Mm-hmm.
Well, maybe we can get away with letting, if we're lucky, we can get away with letting this be the u and letting this and that be the dv. Because then uv minus integral of v du, well, u equal, I saw other people had questions. I'm sorry. Just give me a second here. I'll get this out of my system. See, the thing about this one is dv is x dx, so v is 1/2 x squared. So this is 1/2 x squared times the natural log of 3x minus the integral of 1/2 x squared times dx over x. And see, that's not bad. That's just the integral of x dx. So we're left with, yeah, it ends up being 1/4 x squared plus a constant.
Why wouldn't it be 1/4 x?
The thing I have not shown is that this is the integral, 1/2 the integral of x dx. With a minus, I mean. Because the x's the 2 and the x downstairs cancels and leaves you with integral of x dx, which is 1/2 x squared. The 1/2 times 1/2 gives you 1/4, and the minus rides along. That would be I think that was a homework problem, so that'd be a fair exam question. Yes?
Just for clarification, on the previous, would it be minus x minus 2? Or negative x minus 2, because minus w, and you have to distribute that negative to 2.
Oh, thank you. Thank you. I should do that, or I should distribute the minus, yeah. I mean, the point is I should really put parentheses in to be safe. Or, like you said, I can just put minus x and minus 2. Yeah. Yeah.
I had a question on the problem in blue. So you did it a different way. You said it was easier. My question is, you let x equal to x, or you let w equal x plus 2, and then dx just turned into du. I don't understand how you can just change dx to dw.
Well, dx is equal to dw. If w is equal to x plus 2, this says that dw is equal to dx, right?
Would that work if you had like x squared plus 2x? Would you then say the same thing?
No. This kind of, I mean, only if you have x plus some number.
Yeah. But then when you derive it,
Yeah.
it's just 1. Right?
Right. dw dx is just 1, right?
Okay. Thank you.
Mm-hmm. What were the other? There was another question here before I got off track on this. You guys are making me work today. Why can't you ask questions about an easier section? Did you have questions about? You don't have any questions about like functions of two variables or?
Can we talk about the last
We
section?
will ask questions if you don't put this on.
Yeah.
Funny. Anyway, yes.
So, how many questions are maybe not getting?
Oh, enough?
Right, was it gonna be like 20?
I have no great joy of grading, so I don't think your final is going to be like super, super long. You know. Well, if I make certain problems hard enough, then you all leave them blank. So there's that. But
No, he did. That's not nice.
it's not nice. I would encourage you to study the old exams and make sure you know how to do the homework problems, especially ones that have happened since the last exam, right? That's the part you haven't been tested on yet, which is the most likely to kind of sneak up on you. That and the definition derivative. What is it? Remember this? Show f of x equals to x squared has f prime of a equals to 2a from definition of derivative. Remember that?
Wait, isn't it the really long equation?
Yeah, I'm not joking. I'm so not joking. You guys. Oh, am I allowed to erase this?
Well, you already did.
I mean,
Just as long as you put it up in the recording.
well, you have
I'll have it down there.
you have to. You got it? But I mean, I did this like 5 minutes ago.
And then you were talking about the H thing.
I can stop. I mean, I'll stop right there. We can leave this.
Is it that?
There you go.
Wait, is that the f of a minus f of h?
If this board were cleaner, I wouldn't be able to do that. What's that?
Are you talking about the definition, the f of, what, you know, what's saying f of a minus f of h?
Right. Remember, f prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h, which for the f I have over there would be the limit as h goes to 0 of a plus h quantity squared minus a squared divided by h, which is the limit as h goes to 0 of a squared plus 2ah plus h squared minus a squared. You guys are like, physically revulsed by what I'm doing right now. It's it's funny. Yeah.
So we're gonna have to.
Like we did before, right? So therefore, f prime of a is equal to 2a. I don't know. What did I ask on the first test? I mean, there's about 3 or 4 different standard problems that I can ask there. The squared function, the linear function, the reciprocal function, the square root function. 1 over the squared function is another popular test question. I don't know. What did I do? It's been like forever. Let me remind myself.
Oh, yeah, okay, this is, yeah.
No memento. Yes, you have a question?
On the last homework, can you go over one of the last 2 questions?
Certainly. With gladness, I will do that. Let's see here. Aw, man. I was tricked. There's a Math 126 folder on this computer. My wife used this computer for about 2 months. It's her Math 126 folder. So I do not have... Oh, but we have it in Blackboard, right? I guess I could look in Blackboard. Now, you had a question about, you said, which problem in the last one?
This is one of the last 2 that has
Which one, 7 or 8, 9, 10? 9 or 10? I'll look at 9 then. Yeah, I hope you guys understand integration by parts. I don't really look to, I would usually test one of the easier problems, because, I think it's a difficult topic, so, I don't, but I don't think any of the ones in your homework were like super difficult, so. What I was talking about is integration by parts. Yeah. What am I doing? It's homework 18, number 9. So here we have f of xy equal to x squared minus y squared minus 6x plus 8y plus 2. And you're supposed to find any critical points. And classify them. Min, max, saddle. Oh, and also find the actual value. Okay, so remember critical points meant what? That meant fx and fy are both 0, right? Fx is what? It's 2x minus 6. Fy minus 2y plus 8. So 2x is equal to 6, and 2y is equal to 8. So that tells me that x is equal to 3. This tells me that y is equal to 4. Sorry, I'd make up a new problem that I hadn't already worked, but I'm not going to change it because what invariably happens when I change these problems, even so ever so slightly, is they become much harder. Anyway, okay, so then what? So that's the critical point. Now I have to calculate the so-called Hessian. So D is fxx fyy minus fxy squared. Remember, this is what we use. This is our second derivative test. If D is positive or D is negative, we can decide whether it's a min-max or saddle. So what is that actually here? Xx is what? 2? Yy? Negative 2. Xy? 0. So this is minus 4, less than 0. Therefore, f of 3 comma 4, which is equal to 9 minus 16 minus 3 times 3 plus 8 times 4 plus 2, which is what? Minus 25 plus 32, 7, 9, 18. Hence, is at a saddle point. I mean, the saddle point is actually 3, 4, 18, right? For what it's worth. You could say that the saddle point's at 3, 4. If I don't ask about the value of the function, you don't necessarily have to find it. I mean, depends on the wording of the question. Like problem 8 or problem 9 actually says determine the relative extremity of the function if it doesn't exist, or if it doesn't exist, enter DNE. Now this one's DNE, right? But if it had existed, you would have wanted to know that it was 18.
So
18. You're fine. Go ahead.
So every saddle point, there's no minimum or maximum.
Right. Saddle points are. It's not. You know. It's like a saddle, right? Your legs go down, but the saddle goes up the other way. So if you're at the saddle point, you can go up in these directions, right? But you can go down in those directions. So it's not a max or a min. There's a way to go up and a way to go down at a saddle point.
And you determine whether it's max, min, or saddle by that method.
Maybe I'll put the monkey saddle on the final.
What? A monkey.
There's a monkey saddle. There's a dog saddle. There's all kinds of fascinating stuff.
Do you mean like with pictures?
Like somebody's named it a monkey saddle. It's like there's this particular curve called the monkey saddle. I will try to keep the problem somewhat similar to what's in the homework, of course. But anyway, does that help with that? Here, let's look back at test 1 for a second if I can get it. Come on. So what I do when I'm making a final in here usually is, or any class really, I go back and look at my old tests, see what I did, try to put something together that sees, can you still do those things? And or have you figured out how to correct the mistakes you made before, right? So I want to reward you if you have figured out how to do that. So you remember we did stuff with algebra, we did rationalization, we did limits, we had graphical limit questions. Those are easy. Oh, here's the example that was actually on the test, was the reciprocal function, right? Remember that? I remember that. I did not enjoy grading that problem.
Oh yeah, that. Go back up.
Oh, look. What's that?
Yeah, that's the one that.
Yeah, there was much abuse of notation in this problem, but I've come to terms with it. It's okay. Oh, look, this is back when Trump getting out of the race was still believable. Haha. Let's see here. Oh yeah, the intermediate value theorem. Remember, that's the theorem that says if you have a continuous function and you have two values, then it hits every value which is in between those values on the interval. The intermediate value theorem, that's what allows us to use sign charts for graphing and everything. Equations for tangent lines. Here's a big hint. If your equation for the tangent line has anything except for numbers and x's which are appearing in the numerator, like linearly, like this kind of expression, like a line has the form mx plus b. If you have an x squared or division by x cubed or anything except for y equals mx plus b, or perhaps a number times, plus another number times x minus number. The point is, if you multiply the expression out, you will get back to y equals mx plus b, right? If it's anything except for that, it is not the equation of a line. This is a good rule of thumb. Now, I think I may be talking to people who already dropped the course. If I am, I'm sorry. But anyway. I hope if I ask about an equation for a tangent line, you guys all get it. It is bad. Don't forget these ones. These will sneak up and get you. These symbolic ones, basically, this is just you have to be able to think symbolically and use data which is given to you, right? Differentiation. Ah, yes. Remember when we used to differentiate? Thankfully, that's all gone now, right? We're not differentiating anymore. It's not true, is it? We're always differentiating. So, do you guys remember this problem? I talked about this in class for about 90 minutes. And it did not go well on the test. Oh, what did I say? I said, I like to test on the final and see if the students could understand what it is that they didn't understand before. That would seem to include this problem. You can ignore this problem in your studying. It's your prerogative. Whatever floats your boat. Que sera, sera, so forth and so on. Anyway, but if you look at the notation on the test, I think it's a nice notation to understand how to do this problem. Basically differentiate the different cases and make them match in the middle, and then use continuity to match the other point. It's really not that bad if you look at it again. Maybe you'll understand it more if you look back at it again. That was test 1. What was test 2? Unable to connect to the internet. Oh, wait. I'm not sure if it's my laptop or I don't know. Blackboard has been a little bit Am I supposed to?
Well, if you did, this is one of the issues that a lot of people are having if it's changed off your network.
Oh, really? I actually turned off the automatic updates because I hate them with a passion. But if that's actually a thing that's been fixed, I will bite the bullet and allow it to update my computer. Generally speaking, it is very offensive to me that the operating system decides to randomly turn off my computer whenever it feels like. It's my computer. I should decide when to turn off my own computer. Come on. I think Windows is very pushy. Sorry. So here we had chain rule, right? You should definitely review the chain rule. Chain rule is usually a very big part of the final. I like the chain rule. It's important. You must understand it. Second derivatives, they still matter. Implicit differentiation. Do not forget about the implicit differentiation. Equation of a tangent line to a implicitly defined graph, right? There's another kind of problem we worked. Again, the equation for a tangent line is of the form y equals mx plus b, or y is equal to y1 times m times x minus x1, something like that. Oh, related rates. I forgot about these. Oh, man, it's good I saved these tests so I can remember what I did.
Something like that, then I'd be all right.
How about differential? Don't. If I asked a question about the differential, don't be scared of this. This is just df is f prime of x dx, right? It's just a silly way of asking you how to differentiate again, right? Now, if you think about it, we've been using this differential idea all over the place in integration now, right? Like the dv and the du. That's just df. If you're confused about a word on the final, ask me. I'll probably tell you what it means. That's part of the reason I'm giving you this piece of paper, so that you can write down little notes to yourself like differential means this, you know? Horizontal asymptotes, vertical asymptotes. Remember, vertical asymptotes come from where the function's not defined. There's division by 0. Horizontal asymptotes involve limits at plus or minus infinity, right? Horizontal asymptotes you can cross. Vertical asymptotes you cannot. Horizontal asymptotes you can cross all day long, but the vertical, there's the function's not defined at those points. Unless you're a mathematician and you draw in a dot just to be pathological. Okay. I will not repeat what I just said, as it is pathological. And I don't think is it cool to be sick anymore? I don't know. Being sick, that's like so last year or like 3 years ago? How long was it ago we were saying sick is like something good? Yeah, like that's sick. Is it a saying? Is it still a saying?
I thought you meant like being sick is like not being
No, like when I was in school, it was good to be bad. You know, like Michael Jackson had that "I'm bad" thing, whatever. Graphing with calculus. Oh, I do love graphing with calculus. Oh man, I forgot about that. We haven't done this in a while. That was fun. I guess I'm in the process. Thanks for you guys. You guys are helping me make the test right now. Thanks. Reminding me of all these things. It's so helpful. Hey, when is our final?
It's on Tuesday at 10:30.
Tuesday at 10:30 here, right? Yeah. If I'm later than 10 minutes, then I'll just take the average year test for the final and save myself some grading. Woo!
Oh, yeah.
I mean, I'd take the average of all the tests and then give everyone the same grade. No?
Why are we getting punished?
Because I wanted to make sure that the people who did well on the test show up for the final, so that I have some kind of metric for whether or not it's hard. All right, so and then there's test 3. That happened too, didn't it? Oh, exponentials and logs. I like those. And then you got the maximization problem. Yeah. This is a little bit fresher, right? I think I said about 25% for each test, and then 25% for like the material since the last test, right? An announcement, I said that. Anyway, that's about all I got. So if you got any questions, let me know. Otherwise, see you later.